Hey, we're live. Look at that. Look at that fireplace. Look at that fireplace right there. That's a nice fireplace. It's very visible in this particular camera angle. I guess I moved my computer desk around last time. So, yeah, it's looking good. Hey, how we doing? It's a nice Monday night tonight. Had a weird day at school, though. It's just a little weird. You know, the vibes with the coronavirus kind of conversation starting. It's a little weird, but we make it work. We'll keep pushing onward. After all, we need to make sure we get to the 6162 AP Calculus quiz. Is the utmost importance because it's fun, and we like the 6162 AP Calculus quiz. Cool beans. So, how's everyone doing tonight? Checking the chat. We got no comments in the chat right now. That's a sad chat. Sad face in the chat. I'm not actually going to put a sad face in the chat because I don't want the chat to actually be a sad face. Although, in accordance to the sad face emoji that would have ended up in the chat, my living room ceiling has a nice leak in it, which has been preoccupying me. So, yeah, that's kind of what's going on in my world. Yep, just go ahead and wait for confirmation in the chat. And then we're going to jump in. Got some exciting live review tonight, 6162 integration of slope fields. It's going to be fun stuff. I hope everyone's enjoying it. We got a like already. A like before a comment. Wow, that's great. Like before a comment. Good times. Oh, we went from 2 viewers to 1 viewer. Apparently, the stream wasn't good for that 1 viewer. But yeah, we're back to 2. Let me know if everything's working in the chat. Camera angle's good, and we will get started. Go ahead and prep the notes. Install later. I think I clicked that last time I streamed. Logitech, you'll never upgrade your software. Sorry. Okay, this is what we want. We want this today. A little bit of notes. A lot of Mr. Jackson. No, that's good. That's good. And we'll put me like right over here. Hopefully not bothering anyone. Great. We're back to the chat. Chat, how you doing? Oh, great, Willis. Nice to see you. Hope you're having a nice night. We're going to go ahead and jump in. Time is always of the essence, and we've got Netflixing to watch, of course. So let's go ahead and jump into the 6162 live review with my Boromir meme to start things off right. First of all, I prepped a topic list for you. By the way, some people ask me, is that noise my fire alarm in the background? It's just one of my armchair handles is squeaky, so that's what that is. It's not the fire alarm going off. I know sometimes when you have a low battery, it does that beep every so often, but that's just my armchair. Yes, thanks, Willis. Good meme. So topic list for this particular unit. Number 1, evaluate both definite and indefinite integrals. Number 2, evaluate definite and indefinite integrals using substitution. Just checking our mind real quick. Is it not working for Jackson? Sorry, Jackson. Jackson is dedicated and was watching from the bus. But it says the video is unavailable for Jackson. Oh, sorry, Jackson. Jackson, you'll have to catch it on live. But I know Jackson's not missed a live review, so he's pretty devastated by that. We're back, and we're doing initial value problems. That's when I give you a particular differential and a coordinate point, and you have to work backwards. Drawing a slope field by hand is important. Sketching a solution curve to a slope field going through a specific point. So that's when you draw your slope field, and then I ask you to sketch one of the lines that goes through a point. It kind of follows the trend of the data. And then using a differential equation to find the solution curve of a slope field. And then, of course, knowing your derivative facts. So you got to make sure you know your derivative facts because all your antiderivative facts are just based on your normal derivative facts. So as long as you know your derivative facts, you can reverse them and calculate any antiderivative. Okay, so we are good to go. Keep on rolling. I just prepared a bunch of problems, and I'll leave a little bit of time at the end to see if there are any questions or concerns. Let's go ahead and jump into these problems. Okay, so first off, maybe go like that big. We've got the integral of cosecant squared of u du. So there's no u substitution here needed, just antiderivative facts. And if you remember, the derivative of the function cotangent was equal to negative cosecant squared x, right? So then the antiderivative of cosecant is going to be some version of cotangent. But if you want to make sure you check your work, if I were to just think the answer is cotan x plus c, the derivative of cotangent would actually give me negative cosecant squared. So I would need to make sure I negate the entire polynomial or the trigonometric function, in order to make sure that the derivative of the negative cotangent x the derivative of the negative cotangent x is going to give me a positive cosecant squared because the derivative itself is already negative. So that is what I would say would be the best answer. Hi, Trevor. How are you tonight? Let's go ahead and keep going. We're doing basic antiderivative facts here. We're not using U substitution. So in this particular problem, we're going to take the antiderivative of each term. So we're going to start with 2e to the x, which just has antiderivative 2e to the x. Pretty simple. And then this middle term here, secant x tan x, is a derivative fact. It's the derivative of secant x. So this is just secant x. And then minus, this is, I'm going to write this up here as x to the 1/2 power. So if I take the antiderivative of something, I have to add 1 to the power and divide by that new power. So this is actually going to be x to the 3/2 power, because that's 1/2 plus 1, divided by 3/2 plus c. So if I clean this up, this is 2e to the x plus secant x minus 2/3 x to the 3/2 plus c. And this would be the final solution. Integral, no U substitution needed. Let's just go ahead and use our antiderivative fact. So I'm going to do the work down here. So if you're taking the antiderivative of a polynomial, you just add 1 to the power. So this becomes x to the -1 over -1. And then we're going to do plus, and this is 6x cubed over 3. Add 1 to the power and divide by that power. And so then this just is plus c. And so if you simplify the 6 and the 3, you get 2x cubed in the middle, which looks like it corresponds to choice B, -x to the -1 plus 2x cubed plus c. All right? Great. Getting some good practice here. Let's try this one. We saw this one today in the little activity. This is a U substitution needed now. You can't take the antiderivative of this unless you actually expand the polynomial, which nobody wants to cube that thing and then multiply it by 28. That'd be quite tedious. In fact, the problem is very easy if you let u be 7x minus 2. And therefore, du would be 7dx, and dx would be 1/7 du. So now all you have to do is plug back in. So you get the integral of 28u cubed times 1/7 du. Okay? And then the 28 divided by the 7 can actually just come outside the integral. 28/7 is 4. 28/7 is 4. And then this is u cubed du. And then you have to take the antiderivative using your normal fact. U to the 3rd power, you'd have to add 1. So this would be u to the 4th divide 4 plus c. And then you have to plug u back in. So the final answer could be 4 times 7x minus 2 raised to the power of 4 over 4 plus c. Or if you want to simplify your 4s, this could be 7x minus 2 to the 4th plus c over 4. Now, either one of these answer choices is appropriate. I like the left one a little bit better than the right one. Okay? Hey, that was on the Quizlet Live, which I won. Nice job, Willis. Good work. Okay, so we are good. That's a nice problem. Here we go. Here's another one. This is the square root of tan x times secant squared x dx. One of the things that you're starting to get the hang of, hopefully, is that the derivative of tangent is secant squared. That's my perfect u in order to cancel the secant squared x. Also, the left term has more layers, right? This left term is the square root of a trig function, and the right function, actually, you could argue secant squared is 2 layers itself, so it's actually a 2-layer versus 2-layer. But if I let u be tangent, okay, then du is actually going to be secant squared x dx, and this is what I kind of saw. I'd get 1 over secant squared x du. And I know that 1 over secant squared is going to cancel with that secant squared. I'm in business, okay? So this is going to be the integral of root u times secant squared x times 1 over secant squared x du. So secant squared cancels with secant squared. I get the integral of root u du, which I can now simplify. So this is root u is u to the 1/2 power. And then I just add 1 to the power. So this is just going to be checking the lines out, make sure everything's okay. Oh, it's Jackson. Try to watch it later tonight, though. Definitely, Jackson. I hope when you're watching it, you're comfortable in your house and not on a bus. I know you had the dedication, you were working towards it, but that is okay. So let's go ahead and finish this one. It's a u to the 1/2 power, so it would be u to the 3/2 power divided by 3/2, which is just times 2/3 plus c, and put the tan in and we're done. 2/3 tan x to the 3/2 plus c. The 2/3 does not need to be in parentheses this time. Hi, Patrick.
Hey, Sam.
How you doing?
I was supposed to be quiet.
No, that's all right. My brother-in-law Patrick's here. I'm just saying hi. How you doing? We'll talk later. I'll do some chat.
You don't want to start the conversation, Sam.
I know. I'm well aware I did it, but it's all good.
Well, it's like, he's doing this live thing with math and stuff. I'm like, oh.
You close the door. Patrick says up. Okay. U substitution useful in evaluating this problem. Should be pretty straightforward. If we use a u to be 3x minus 2, I think that life would be good, and we could solve secant squared of u, which of course would just be tan x. The answer would be tan x. So this u would work. Secant squared would not work, obviously, and then I don't know, cosine, what that's going to do. I guess if you did like 1 over cosine squared or something. But yeah, 3x minus 2 is definitely going to work for us. All right? Okay. We are trying this one right now. Ooh, this one looks interesting. I've got sine 2x over 1 minus cosine 2x quantity cubed. I'm thinking possible u's might be 2x or the entire denominator. All right? Let's try the denominator. You know what I'm thinking? If I know that the derivative of a negative cosine would give me a sine, it might be good enough to cancel the sine. But if I chose this to be my u, the derivative of that's just 2, and that's not going to be enough to cancel anything. I think the denominator is the way to go here. So let u be this. So then, be careful taking the derivative of this, okay? So then du is equal to, so this would be the derivative 1 is 0. The derivative negative cosine is sine 2x times the derivative of the inside, which is 2. So sine 2x times 2. So now I have to do dx. Oh, I forgot my dx right here. Dx is equal to 1 over 2 sine 2x du. And I think I'm ready to substitute, okay? So this is going to equal the integral, all right, from sine, and u is the denominator, so I'm just going to leave this, over the denominator cubed times 1 over 2 sine 2x times du. And the sine 2x's wipe each other out, which is good. The 1/2 I'm going to pull out of the integral, so I'm just going to take this, pull it right out of the integral. So we get 1/2 times the integral of, this is the numerator is now just a 1. The denominator is u cubed du, and I'm in business. I can actually integrate this thing. So I'm going to rewrite this as 1/2 integral u to the negative 3 du. Okay, I'm just making sure I'm not cut off my screen. And then I'm going to integrate it, so it's going to be 1/2 on the outside. I'm going to add 1 to the power, so it's going to be u to the negative 2 over negative 2 plus c. And then I'm going to plug my u back in and get 1/2, and let's be strategic here. So it's going to go to the denominator. So let's put a negative 1 on top. 2u, which is 1 minus cosine 2x squared. This is like that. Okay. And then plus c. And again, actually, I wouldn't even want to distribute the 1/2 this time. It wouldn't cancel or anything. It would just become negative 1/4. So I think I'm happy leaving my answer just like this. And that is probably the messiest answer we've ever gotten. That's pretty messy. Okay. Not too bad, though. Be strategic with your u's, okay? Really think about what it would accomplish and what you're trying to cancel. Here's another one. This one is x squared secant squared of x cubed. All right, so let's see. What could u be? You could possibly be x cubed. You know what? I really like that because the derivative of a cubic would give me a quadratic, and maybe that's enough to wipe out that quadratic. Let's try it. Let's try it. So let's just let u be this. So then du is 3x squared dx. So that dx is equal to 1 over 3x squared du. Okay? So then I just plug this stuff in. So this is equal to the integral of x squared du. This is a little messy. I'm just going to scooch these guys over. Okay. x squared bounces with x squared. The 1/3 pulls out of the integral. So this is 1/3 integral secant squared u du. Nice. Secant squared is an antiderivative. It's tangent, tan of u. So this is 1/3 of tan u plus c. And then put the u back in. This is 1/3 tan x cubed plus c. Parentheses maybe not needed there. But I meant the parentheses around the x cubed, maybe not needed there. Your call. You don't, I guess I just erase them. You don't really need them there. But yeah, this is our answer. So that one wasn't too bad. Have the right u as x cubed there, and everything kind of falls into place. Check in the chat. Okay, Jackson made it. Jackson, welcome to the live review. I'm so excited you're here. CJ Hilty, does the 2 in the previous problem not go to the numerator? Let me check, CJ. The 2 in the previous problem. Okay, I'm following along here. Are you talking about this 2 is definitely in the denominator. So denominator. This 2 stays in the denominator. This term goes to the denominator. So it'd be u to the positive 2 on the bottom. So u to the positive 2, and then the negative 2 stays there. I just brought the negative 1 up. I think my answer looks good for that problem, CJ. The negative 2. This one right, yeah, this one right here, CJ. I think this one. I don't know what that was supposed to be, an arrow. I failed art class. Mrs. Tucciaroni, if you're watching this, I'm sorry. I'm done. All right, let's keep pressing onward. Let's try this one. This looks pretty fun. This is x squared plus 1 times x cubed plus 3x, all to the negative 5th. I'm thinking this has to be our u, and it looks good too because the derivative of the cubic gives me a quadratic, possibly enough to cancel with that left quadratic. So let's try it. Let u be x cubed plus 3x. So du is 3x squared plus 3. And so dx, oh, I forgot my dx is equal to 1 over that. But you know what? I can factor a 3 out, can't I? This would be x squared plus 1 du. And you know why I did that? Because look at this. And look at this. Boy, I had a hunch. All right, this is equal to integral of x squared plus 1 times u to the negative 5th times 1 over 3x squared plus 1, and we are at du. And the x squared plus 1 cancels with the x squared plus 1. The 1/3 pulls out of the integral. It's like clockwork at this point. 1/3 integral u to the negative 5th du, which is 1/3 u to the negative 5th is going to be add 1 to the power, so it's going to be u to the negative 4th over negative 4 plus c, which is equal to 1/3. Okay, u is x cubed plus 3x. Let's put it on the bottom. So I'll put the negative 1 on top, the 4 here, x cubed plus 3x raised to the power of positive 4 plus c. And whether or not you want to multiply the 1/3 out, that is entirely up to you. Check in the chat. The chat is good. We are chilling. I hope you guys are having a nice night or morning or afternoon whenever you're watching this live review. Good stuff. Okay. Ooh, look at this one. What's this one? 1 over root x sine root x. Well, I'm thinking root x has to be our u. There's really not anything else I could pick. So let u equal root x. And so du is equal to, so this is equal to x to the 1/2, right? So the derivative of such is 1/2 x to the negative 1/2 dx. And I'm just going to rewrite that. That's 1 over 2 root x dx. Okay, just rewriting that. So dx is 2 root x du. And I think I'm ready. I'm loving it. 2 root x is going to cancel with the 1 over root x, right? The root x's are going to cancel. So this is the integral of 1 over root x sine of u times 2 root x du. And then root x cancels with root x. The 2 comes out of the integral, giving me 2 integral sine u du. So I take the antiderivative of sine. That's the function that would, its derivative would give me sine. That's going to be a negative cosine. So 2 parentheses negative cosine u plus c. Just to check my work, the derivative of cosine is a negative sign. So the derivative of a negative cosine would be negative sign. It'd be positive sign. So that worked. Final answer, 2 times negative cosine root x plus c. And again, if you want to distribute the 2, that's fine. If you want to leave it like this, this is the proper answer. Okay. For some reason, I decided to use my u as x cubed plus 3x with a minus 1 for the previous problem. Go back, Jackson. Go back. X cubed plus 3x. I'd like to try that. You could try that. Oh, whoops. Ooh, I added a blank page. Okay. I thought I copied the page, but I just added a blank one. That's fine. We can get around that by just copying this and pasting it here. Oh, that's neat. It pasted my highlight. How unfortunate. We're going to delete the highlight. Copy the problem. Here we go. Oh, this is so much work when I could have just rewritten it, but I've come too far now, haven't I? Okay, so Jackson says he uses x cubed plus 3x to the negative 1. So let u equal x cubed plus 3x to the negative 1. So du would equal, oh my gosh, so this is going to be tough. This is going to be negative 1 x cubed plus 3x to the 0 times by the derivative of the inside. The derivative of the inside is 3x squared plus 3, which this becomes 1. So this is negative 3x cubed minus 3 is du, dx. Okay, Jackson, I think this is going to work, ironically. So dx is 1 over negative 3 factored out, x cubed minus 1. Oh, it's supposed to be a square. No, I made a mistake. It's supposed to be a square. So, bye, Patrick. All right, bye. Okay, bye. See you later. Have fun.
I'm more important.
I guess. Okay, so we're back here. This is supposed to be a square on the denominator, so it's looking okay. And it's supposed to be negative 3. Okay, so it's plus now, plus 1. du. I think we're okay. This is the integral x squared plus 1. And then x cubed plus 3x is now our, we got to be careful here. So if x cubed plus 3x to the negative 1 is our u, then this is just u to the 5th, positive 5, right? Because it would be x cubed plus 3x to the negative 1, which is our u, raised to the power of, not sure why that's a circle, raised to the power of 5. Because then if you multiply the exponents, you get negative 5. So this is u to the 5th times 1 over negative 3x squared plus 1 du. Cancel, cancel, equals negative 1/3 integral u to the 5th du, which equals negative 1/3. And then this is going to be u to the 6th over 6 plus c. And then we put the thingy back. Negative 1/3 times x cubed plus 3x to the negative 6th over 6 plus c. So we got to put it on the bottom. So this is negative 1/3, 1 over 6x cubed plus 3x to the positive 6 now. Positive 6 plus c. Did it work? I think so. Let's go back and check. I don't remember the answer.
There is no incoming call.
Thanks. Anyone else have an Alexa that just talks randomly? I didn't get the same answer. What happened? It looked like it was okay for a bit. Did I make an algebraic mistake? X cubed plus 3x to the negative 1. That's fine. And then we took the derivative. Did we take the derivative properly? So negative 1 comes down. And then x cubed plus 3x to the 0, because you have to add 1 to the power for derivatives. Oh, we get the minus 1 to the power for derivatives. I was doing the integral rule. This should be negative 2nd power. This right here is an error. This is an error, right? You'd have to minus 1, so it'd be negative 2nd power. This would be negative 2nd power, right? So, oh my goodness. This is not going to work, Jackson. Yeah. This is not going to work because now you've got a derivative that's super nasty. Let's see if we can clean it up. So du equals negative 3x squared plus 3 over x cubed plus 3x squared dx. So dx equals the reciprocal, x cubed plus 3x squared over negative 3x squared plus 3 du. Because I made it, I got the same answer. I think I got it the same answer because I made it to cancel. This is going to work if we push forward with it. X cubed plus 3x is going to, the denominator is going to cancel. Yep. Okay. Let's see what happens. I'm kind of curious now. I would never do this, though. I would definitely use a positive power. It's going to, oh, geez. It's going to be so much easier to use a positive power. Okay, we are deleting this. Let's see if it works. All right, so this is the integral of, we'll change the color just so I don't get confused. Go back to red. Integral of x squared plus 1 times, all right, so my u is that, so this is going to be u to the 5th, right? U to the 5th, because it's the negative first power, and then times this, which is x cubed plus 3x squared over negative 3x squared plus 3 du. So this definitely cancels it. I have to factor, but it cancels. So why don't I just pull a 3 out, and then this will go away, and this will become 1. So this definitely cancels with this. So I have equals the integral negative 1/3. So my negative 1/3's out. And then I've got u to the 5th times x cubed plus 3x squared. X cubed plus 3x squared du. X cubed plus 3x squared could probably be written again with a u. So it's x cubed plus 3x to the negative 1 is u. So if I raise it to the negative 2, it'll give me positive 2, right? So it'll give me positive 2. So I need to do u to the negative 2. I need to do u to the negative 2. So this is negative 1/3 integral u to the, so 5 minus 2 is 3 du. So then I do my integration, and it is going to work. So I'm going to get u to the 4th over 4 plus c. Life is good. We're going to plug back in. I'm not going to do the rest because we spent a lot of time in this one, but it does work, Jackson. It looks good indeed. Good stuff. You do get the same answer. I would definitely not do that, though, Jackson. I would use x cubed plus 3x as my u and not to the negative first power. Just a little easier on the algebra. Okay, here's another one. Let's see, x minus 1 in parentheses here, squared. So don't get confused by this dx. It could just be chilling out here. So I'm going to let u be the denominator so that du is equal to 1 dx. No need to isolate dx whenever you get du equals dx. It's just the same thing. So this is going to be the integral of 1 over u squared du. And I'm ready. I can just call this u to the negative 2 if I prefer. U to the negative 2. So if I solve this as u to the negative 2, I get u to the negative 1 over negative 1 plus c. And all I have to do is put my x minus 1 back in. I'm ready. This is negative 1 over x minus 1 plus c. Because the denominator would just be the u to the negative 1, which goes down, comes u to the positive 1. And the numerator, negative 1, I just brought the negative up instead of keeping it on the denominator. All right? Cool. Yes, awesome. Okay, here's another one. Root x plus 1. This seems simple enough, but a u substitution is required. Let's let u be x plus 1, such that du is going to be 1 dx again. No need to go any further. So I'm just going to scooch this over a bit. Scooch, scooch. This is the integral of root u du, which is the integral of u to the 1/2 du. which is 2/3 u to the 3/2 plus c, which is 2/3 x plus 1 to the 3/2 plus c. That one's pretty straightforward. You could probably even maybe do that one without a u substitution because the derivative of the inside is just 1. No chain rule required. You would not need a u sub there. You would not need a u sub there. Gonna go watch the rest later. I'm gonna request to go over some u substitution tips, like what to do for away and like how do you know absolute value. Absolutely, Jackson. Yes, thanks for joining us. Jackson asked for some tips. I'll go back and read those again before the end, and we'll see if we can talk about those. Absolute value. Absolutely, Jackson. Yes, thanks for joining us. Jackson asked for some tips. I'll go back and read those again before the end, and we'll see if we can talk about those. So let's try it. 10 minus x squared. So du is 10 goes away, so then it's negative 2x dx. So dx is negative 1 over 2x du. Okay? Let's see if we can try this. This looks pretty simple. This is the integral of 3x over the cube root of u, which I'm going to write as u to the 1/3. All right, are we cool with that? I don't like writing the cube root, I like u to the 1/3 power. Times negative 1 over 2x plus c. X's cancel. The negative 3/2 I'm going to bring out of the integral. And then it's going to be 1 over u to the 1/3. I don't know why I wrote a plus c halves. And then we're going to do the, actually, no, we'll write it like this first. U to the negative 1/3 du. Okay, now we're ready to take the antiderivative. So it is negative 3/2. Now I'm going to add 1 to the power. So if I add 3/3 to 1/3, I get negative 1/3. I get 2/3. So u to the 2/3 divided by 2/3 plus c. And so if I clean this up and I put the u back, it's going to be negative 3/2 parentheses. The 2/3 becomes another 3/2. 10 minus x squared to the 2/3 plus c. And this is my answer. And we'll get a bit of water. A bit of water. Here we go. Good stuff. Okay, time to shift to some definite integrals. Looking this time at the integral of negative 1 to 1 of this expression. Obviously, you need a u substitution here, right? You can't solve this integral without it. So let's let u be the denominator 4 plus r squared, okay? So 4 plus r squared. So du is going to equal, what is this, 2r dr. So dr is equal to 1 over 2r du. If this r confuses you, just go ahead, go to the original problem, make these r's turn to x's, and then solve it like normal, okay? So don't let different variables confuse you. It's all the same. So I think I'm ready to do my integral, but I need to change my bounds. So let's find the u bounds. U bound at 1 and u bound at negative 1. So plug them in. 4 plus r squared is 5. 4 plus 1 is 5. 4 plus r squared is still 5. Interesting. I think I know where this is going. This is the integral from 5 to 5. Huh. I really don't have to do any work, do I? The integral from 5 to 5 of anything is 0. So I'm just going to kind of stop and just say the answer is 0. Done. Problem solved. Let's try this one. It's the integral from negative pi over 4 to 0 of tan x secant squared x dx. Hopefully you're getting a little used to this now. You see the tan and the secant squared together, your u is going to be tan because its derivative secant squared will cancel with the secant squared. So let's let u equal tan x. Du is equal to secant squared x dx. And so then dx is 1 over secant squared x du. And then you just have to plug it back in. We do have to switch our bounds, though. Let's switch our bounds. Let's find the u bound at 0 is tan of 0 is 0. U bound of negative pi over 4 is tan of negative pi over 4, which I believe is negative 1. And so we then solve. So integral negative 1 to 0 of, so this is tan, oops, that's now u. So u secant squared x, 1 over secant squared x du. Gone, gone, equals, equals, integral negative 1 to 0 of u du. It's nice and easy. Just 1/2 u squared, right? This is a definite integral, okay? So make sure when you do a definite integral, you do your antiderivative, no plus c. It's definite, no plus c. And you put your bounds over here, okay? And then you solve using the fundamental theorem part 2, which says you do your upper bound first. So your upper bound first, which is just 0, minus your lower bound, which is 1/2, and u to the negative 1/2 is just negative 1. So it would be negative, or no, it'd be 1/2, positive 1/2. And then it'd be the final answer of 0 minus 1/2 is negative 1/2. And there's my final answer. Okay, so it's solving a definite integral is very similar. Just doing that. Stay hydrated, Mr. Schachter. Thanks, Trevor. Very important to stay hydrated. Okay, let's see what we got here. What is the solution to the differential equation? Okay, this time I give you a differential and I ask you to find the exact solution that goes through negative 1, 2. So our job is to integrate this, okay, and then plug in the point. Do we need a u sub here? Nah, this is easy. So the antiderivative 3x squared would be 3x cubed over 3 minus the antiderivative 2 would be 2x plus c, which can simplify, of course, to get x cubed minus 2x plus c. And my job now is to plug in the initial condition. So I'll write at negative 1 comma 2. And I'm going to set the y value equal to 2. The x value negative 1 cubed minus 2 times negative 1 plus c. Negative 1 cubed is negative 1 still. Negative 2 times negative 1 makes plus 2. So I believe c is going to equal, so this would be 1 plus c. So c is going to equal 1. So now that I know c is 1, I just go back to my original, ooh, that was an ugly color. Let's pick this one. Original inequality, or my antiderivative here. And I plug in a c. So it'd be x cubed minus 2x plus 1. And that's my y equals my original expression, or equation rather, y equals x cubed minus 2x plus 1. So that solves the differential as a solution to the differential, and it passes through negative 1 comma 2. All right. I have to go. Bye, Trevor. Thanks. Have a good night. Take care. Okay, we've got slope fields. Taking a look at this, it says the slope field for the differential will have vertical segments when. And it looks like in this example, it's going to be vertical when the denominator is 0, right? So set these equal to 0. So we get 4x plus 2y equals to 0. If I isolate y, I get 2y equals negative 4x. Y equals negative 2x. Answer A. Negative 2x. Y equals negative 2x. Oh, that's not negative 2x. Oh! There's negative 2x. Almost got me. Multiple choices. Almost got me. Nice. Okay. Let's keep pushing through. Differential dy dx is f of x leads to the slope field. Which of the following could be the integral of f of x? So basically, the integral of f of x is going to be what function seems to be showcased here. And I think we did this in class. This is just a sine x plus c. Reason because the slope field contains a bunch of different sine curves. All right, there's definitely your sine curves. Let's try this. So AP FRQ. It is, consider the differential negative xy squared over 2. Let y equals f of x be the particular solution to this differential with f of negative 1 equals 2. On the axis provided, sketch a slope field. All right, well, this shouldn't be too bad. Interestingly enough, if I look at the numerator, if x or y is 0, the slope is 0, right? So I know I'm horizontal here, 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 and here. Okay? So I know all those are horizontals. So I really only have to test a couple of other points. Let's make a table to test the other points, because I know some of you like to do that. So let's test x, let's test y, let's calculate the slope. And I've got 6 points to test. So first point, negative 1, 1. If I plug them into my slope field, so negative 1 times negative 1 would be positive 1 times y slope. Okay? And then I do 1, 1. And then I'll just do them real quick. 1, 2, 2, 1, 2, 2. Okay, so let's test. So 1, 1. All right, so now that it's going to be a negative slope, it's just going to be 1, so negative 1. And then I'm going to try 1 comma 2, so it's going to be a negative slope still. And it's going to be 1 times 2, 2 squared is 4, negative 4. Okay, and then we'll do 2 comma 1. So this time it's going to be negative 2 times 1 is negative 2. And that's at 2 comma 1, which is like right here. And then at 2, 2, it's going to be quite big. So the 2 squared, the y squared, makes it 4, times the negative 2 in front makes it negative 8. So it's going to be very, very steep negative slope, something like that. All right, and there's our slope field. Let's take my table and scooch it over. Okay, and then it says B, write an equation for the tangent line to the graph at x equals negative 1. Well, at x equals negative 1, we need to go ahead and figure out, okay, so it says initial condition negative 1 equals 2. So I think I'm going to, actually, let's just find the point. At x equals negative 1, I need to find the slope. I guess I'm using this point. Write an equation for the line at x equals negative 1. Okay. Yeah, I think I'm using f of negative 1 as 2. I guess that's what we'll do. So the point is negative 1, 2. The slope is, I'm going to find this slope here at negative 1, 2, and I already did. It's at 4. And so the slope is 4. Oops, don't fall down. All right. I think that's right. Usually it gives me the point. I guess the point's just negative 1 comma 2. Write the equation to the tangent line at the graph of x equals negative 1. Okay, x equals negative 1 a bunch of times. But I guess the only point we can use is negative 1 comma 2 because that's the point that it gives us. In negative 1 comma 2, we found the slope to be 4. Verifying that slope, negative, negative makes positive. 2 squared makes 4. I think that's good. This looks good. This looks like a solid equation of line. Chat, we agree? Oh, I think chat's gone. Some chat left. One person left in the chat. Hey, one viewer. You're awesome for viewing live. I know not everybody can, but you are still awesome, one viewer. All right, ladies and gentlemen, we've got our last question in the live review that I prepped. It says, find the particular solution through the curve given y of 0 equals 1, and the differential is 2x over x squared plus 1. Obviously, the goal is to integrate the differential and to plug in the point 0 comma 1. Okay? So if we integrate the differential, we are going to need a u substitution here. So let's let u be the denominator, x squared plus 1 dx. So it's no dx here. Oops. Jump in the gun. Here we go. So du is equal to 2x dx, and dx is equal to 1 over 2x du. So I think I'm ready. I'm going to do the work down here. Integral 2x over u times 1 over 2x times du, 2x, 2x. This brings me to the integral of 1 over u du, which we know to be the natural log of absolute value of u plus c. This is one of Jackson's comments. Actually here for another 2 seconds. Hey, Jackson. I was actually just talking about the natural log question that you had posed. The natural log absolute value, it's a good habit to just always put the inside in absolute value, even if it's something that like x squared plus 1 that can never be negative or 0. Definitely, I would always put it in absolute value. So this is going to yield natural log of x squared plus 1, close absolute value plus c. And again, it's not necessary if you wanted to do that, but it is good habit. Let's go ahead and plug in my initial condition now. So y equals ln absolute, 0 goes in. We're going to solve for c. So this is 1 equals natural log of absolute value 1 plus c, which I believe natural log of 1 is 0. So c is simply 1. I know I'm kind of dipping down into the bottom here. So y is going to equal natural log absolute x squared plus 1, close absolute plus 1 is my general solution. That was all just the answer to part A. I didn't really leave you enough space there. Remember that absolute value. Awesome. Good stuff, Jackson. Last but not least, for what values of x is the graph of y equals f of x concave up or down? Justify your answer. Let's see if we can add a page. Actually, I would just do this right at the bottom here. So what I need is the differential down here. And I want to figure out when it's concave up or down, right? So I just need to take its derivative. So let's go ahead and do d squared y dx squared. So this is low d high. So low d high is derivative high minus high d low is 2x, all divided by the bottom squared. And if I clean up the numerator, I get 2x squared plus 2 minus 4x squared over the denominator, which equals negative 2x squared plus 2 over the denominator, which I could factor if I wanted to. Negative 2x squared plus 1 over x squared plus 1 squared. That's nice. Cancels with that, giving me negative 2 over x squared plus 1. No, that's not right. I made a negative mistake. That's not supposed to do that. Here we go. We're going back for a second. This error, this was an error right here. This is negative 2x squared plus 2. Okay, that's looking better now. Over x squared plus 1 squared. And then if I wanted to factor, it would be negative 2 comes out, x squared minus 2 goes in. That's looking better. Over x squared plus 1 quantity squared. We're checking to see if it's still a 2, though. Okay. Checking my derivative. Low d high. Derivative of high is 2. Minus high d low is, yeah, that looks good. Okay. So this is looking good. So this is my derivative. So what I need to figure out is when is the derivative equal to 0? So that's going to equal 0 when the numerator equals 0. So negative, oops, I meant my eraser. Negative 2 times x squared minus 2 equals 0 when x squared equals 2 or x equals plus minus root 2. So if I make a graph of the derivative at negative root 2 and root 2, and I check the signs. Well, let's take a number like negative 100 billion. Plug in a super big negative number. Denominator is positive. Numerator is really, really positive number here, right? Negative 100 billion squared gives me a giant positive. Times by that negative 2 out front, it's going to give me a negative result. Test 0. So we got that done. Test 0, obviously positive on the bottom. 0 goes in here. Negative times a negative makes a positive on top. So positive divided by positive. And then test 100 billion. 100 billion goes in, comes out. Numerator, this left highlighted part is very positive. Times the negative 2 makes a negative denominator there. Or excuse me, a negative function because the numerator would be negative. The denominator would be positive. So we are going to finish up. We have the concave up interval is going to be negative root 2 to root 2. And the concave down interval is going to be negative infinity to negative root 2. Couple of thoughts. Thought number 1, make sure you're being very careful if you're asked to take the antiderivative or the derivative, right? Don't blend your rules together. Antiderivative means you have to add 1 to the power and divide by that new power, whereas derivatives mean you have to minus 1 from the power. On this test, you're doing both quite frequently. Antiderivative when you're actually calculating an antiderivative, but you're doing derivatives a lot when you're doing your u substitution. So just be really careful in that. I'm going back up to read Jackson's comment here. What do I look for with u substitution? So Jackson, the u substitution tip I'd give you is it's typically the inside-most piece of the more complicated layered function, okay? If that fails, just try. Practice, try some, see how it goes. And then I kind of talked about your natural log question. Make sure you always put whatever the natural log is taking inside absolute value. I think you'll be clean. If you have any questions, you can feel free to let me know. Otherwise, I think we're pretty good. If anything comes up, let me know in class. We'll have another little piece of review, and then we'll take that assessment on either Wednesday or Thursday. And we should be good to go. Okay, guys, it's been a pleasure. It's been fun. Have a wonderful night, and remember to always have your plus C's. Got to have it.